and pointers. So let's see the code basically. So we see that at this line we define a two-dimensional array a 2 comma 3. So this is a two-dimensional array, and what we need is that we are initializing it. So this is the first row of the two-dimensional array, this is the second row, and then we are printing a few values. So now the thing is, what are they? So very important thing is again that even though we have a two-dimensional array, but in memory it is all stored in a linear memory. So which means that we have some memory. So 6 elements are there in the 2 into 3 size two-dimensional array. So we have something like this. So we have 6 elements, but they are all contiguous: 2, 3, 4, 5 and 6. So 6 spaces are there. So let's say this is 3000, 3004, 3008, 3012 and 3020. So these are the memory locations, and now we store this two-dimensional array. So it is 12, 15 and 18, and then 1, 2 and 3. So this is the first row. So it is stored here. The first row is stored as 12, 15, 18, and then the second row as 1, 2 and 3. So this is a 0, 0. This is a 0 comma 2. This is a 1 comma 0, and this is a 1 comma 2. So this is the way a two-dimensional array is stored in the memory of the computer. So now the thing is, again, as we saw that the array name is the pointer to the array itself. So this is a, this is the pointer. So if we have, so this is now a double pointer. So we should remember this is now a double pointer. So what it means is that a, if we do star AA, so star star A, it is equal to a of 0 comma 0. So similarly the next thing is star of star A plus 1. So what's this? Now let's try to see. So this A is a double pointer, and so double pointer, when I do a plus 1, so it means now the double pointer has, in each double pointer there are 3 elements. So I move by this much and I come to, so this is the place of a plus 1. So what we do is that when we do a star of a plus 1, so it is now a pointer to this second row of this matrix. And now when we do star of a plus 1 and then a star above it, so it means a of 1 comma 0, and this value is 1, so that should be printed, and ampersand a, so this is now a double pointer, so it will be the memory location where the pointer a is stored. So this was about the theory of this code, which tells us about two-dimensional array and how it is stored linearly in the memory. So again, coming to this code now, so what we see is that let's try to now run this code. So we run this code, and this is the output that we see. So first thing that we see, so let's see the output more clearly little bit. So this is the output, and let's try to see. So we see that this is the first thing that we notice, 12. So this is the value of star a, so that is 12, a00 that we told. Then the next one is a1 comma 0, which is 1 here, and this is the address of a. So now what we see is the address of a is the same as address of a 0 comma 0. So this is a very important observation. So let's mark it as important. So ampersand of a is equal to ampersand of a 0 comma 0. That was true for linear or one-dimensional matrix also. So now we see, so it's moving linearly. We know that int is 4 bytes. So what happens is a00 is 0028FEF0. So next element 01 is at FEF4, then next element is at FEF8, FEFC, then FF00 and FF04. So these are all, we can see that they are all linear, and that's what we try to learn from the example. So most important thing is that all these things are linear memory locations, all the 6 elements. So this is FE, so some number, and then so it is F0, F4, then F of 8, F of C, then it becomes F00, and then F04. So this is what is important. So these are the contiguous memory locations, and this is the first row from here, and then this is the second row. So this is what we need to understand. So first row, then it comes the second row. So this was about two-dimensional array and